All right, this year we have a new award. It's been created to celebrate and recognize BINA members who embody the spirit, the mission, and the values of BINA. So community, inclusion, and excellence. As you heard this morning, Michael Davidson was a pioneer in the bioimaging field, and he profoundly shaped how all of us use imaging as a tool today, and how we understand the world at a microscopic level. His contributions continue to inspire generations of scientists, and as such, we've named a new award in his honor. Before we begin, I'd like to take a moment to extend our deepest gratitude to the family of Michael Davidson, especially his wife, Pamela Davidson, and their family, for allowing us to honor him in this way, as well as Michael W. Halter, John Fraser, and Eric Clark for making the connections to make this award possible. Thank you for allowing us to honor his memory this way. Today, we celebrate his spirit of collaboration and discovery. Before we reveal this year's recipient of the award, I would like to take a moment to acknowledge the 4 finalists. Frederick Bonet, Mariana Denise, Natalie Gaudreau, and Natalie Wu. They're all had exceptional contributions to the bioimaging community in inclusion, education, mentorship, standardization, and advocacy. So let's take a moment to recognize these 4 individuals. And without further ado, I'd like to bring Eric Betzig back to the front here to present this inaugural Michael Davidson Award.
Okay, well, first, again, congratulations to all the nominees. I know that that helping people in imaging corps and mentoring them is not an easy job, and it's oftentimes a thankless job. And so those of us who are instrument developers are completely dependent upon you people to make sure that our technologies get used. And I'm very grateful for everything that you guys do. So without further ado, I would like to present the inaugural recipient of the Michael W. Davidson Award, Beth Cimini. Beth. Congratulations. There is. Mine's broken. There we go. Thank you so much for everything you do, self-profiler, everything else.
Thank you.
We're very indebted.
Thank you. Okay, thank you so much to the committee, to Mariana Denise for nominating me for, and to Pam Davidson and to Eric. I unfortunately never got the chance to know Mike Davidson, but I've heard stories about him back into grad school, and having heard a little bit more about him this morning, I'm all the more honored to be being sort of put in the same class of humans with him. It's really hard for me to put into words exactly how honored I am by this, but it is incredibly, and I am going to try to not cry during this. But the way I'm going to try to not do that is by telling you a little bit about my group and the amazing things that they do. I have links to lots of resources in here. So there's a QR code for the slides. It'll come up again at the end. If there are any of the resources that seem like they'd be interesting to you or somebody that you know and care about. So why did I title this talk, "Thank You, We Worked Hard," in quotations? So this is my lab, as well as some of the alumni and their partners. We were all just at a conference together last week, and so was able to get this picture of a lot of us. There's another thing that you could use to describe this group of people, though, which is the country's largest collection of people who cannot take a compliment on a job well done. I have no idea where they get it from. it has become such a running joke that Esteban Miglietta, who you'll hear a little bit more about later in the talk, has introduced this saying, "Thank you, I work hard," which is the non-thank way of taking the "you did a good job" compliment. And so everyone in this talk who I'm going to give acknowledgements to, because again, when people say that I do a lot for the community, I am representing just a huge number of people who are working very hard. They're all going to be uncomfortable with me thanking them, so I'm just paying it forward. So in terms of what we actually do, and especially the work we do when we're thinking about the community, two things drive a lot of my work personally. Laziness. So in that way, I am a little different than Mike, and I try to, as much as possible, lead with empathy. I did actually write about the laziness part last year, so if that's something you're interested in learning more about, bro.io/Beth Cimini is lazy. But I want to sort of, as I talk about the empathy part, talk a little bit about my own backstory, not because I think my own backstory is particularly special or unique, but because I mostly think that it isn't. I am not a computer scientist at all by training, even though what I'm known for is image analysis. I'm a molecular biologist by training, cell and molecular biologist. And I went to Boston University, Go Terriers, to study this. And I did lots of sample prep and tissue prep and staining and confocal microscopy. And that was amazing. And I was in love with microscopes from the first time I saw a microscopy picture. And then at the end, we got ready to write the paper. And we pulled some representative images. And I asked my boss, Bill Eldred, how do we find the representative images? And he said, just print them all out, organize them by treatment on the floor, and then, figure out what are the conclusions you can draw. Because that's what was done. And I think the reviewers asked us to do one set of line profiles, and, that's what we did. So then I continued in molecular biology. I wanted to get even more molecular. So I went to Liz Blackburn's lab at UCSF to study telomeres. And I wanted to know if telomeres with DNA damage had different properties than telomeres that don't. And so just count how many colocalized and non-colocalized spots you have works for what fraction of telomeres are damaged, but not if you want to know if they have different properties depending on if they are or not. Like, do they travel at different speeds? Which led to the unfortunate realization of, crap, I need to learn to code. I recently did an episode of The Microscopist with Peter O'Toole that I know some of you have talked to me about, where I talked about all of the other things that were going on in my life in grad school that were difficult. This didn't help. The fact that now I needed to learn to code, and I tried really hard to get out of it. I tried asking a lot of my friends to do my analysis for me, and they unsurprisingly were like, no, we're all busy too. So I'm telling you this to bring it back to empathy. Every couple of years, we do a survey of the community, and we ask them, among sort of other things, how much time they spend on the microscope versus on the computer is sort of left to right. And then top to bottom is, how comfortable are you in developing new computational skills? We also ask them to describe their computational skills, but we ask them how comfortable they are too. There's a lot more data in this paper. Suganya Savgurnathan is here and is going to have a poster later this week, so you should ask her more about the data in this survey. But what you'll probably see is that as we get closer to the microscope than to the computer, the comfort number gets lighter colored. There is less comfort going on there. And I remember being so scared about having to learn to code. And so as much as we also want to do things with education to sort of help make it a little bit less scary and help, make all of these things more possible for people who are not computationally comfortable, we also have to meet people where they are. There has to be some movement from us towards them. And so after my PhD, I got the very best job in the world. I went to the Broad Institute and joined the imaging platform, along with at least one future mortgage investigator. And I got to work with Ann Carpenter, and I could just spend this entire 20 minutes talking about Ann Carpenter and how wonderful she is, as well as Shantanu Singh, her co-group leader. I will spare you all that until we get to the cocktail reception, and then I'll probably do it there. But at the imaging platform, I learned to write software that turns images into answers. And I had been a cell profiler fangirl in grad school, and I got to actually work with that tool. And we try to now sort of carry that legacy forward, including into some new tools that I'm going to tell you about. The other thing that has made everything that I'm going to tell you about today possible is I was incredibly lucky that about a year or so after I joined the lab, Anne and Kevin sat down and were like, hey, you know what? Let's write a grant together and let's create something called the Center for Open Bioimage Analysis. And the grant was very well received. So I've been able to spend the last 5 years working in a group that is actually funded to do a combination of tech R&D, driving biological projects where we actually then make technology not just in a vacuum, but in response to biologists' direct needs, as well as do community engagement. So without that funding and my CZI funding as well, so I want to thank that group as well, none of this would have been possible. So thank you, Kevin. I really appreciate that that I have been able to sort of spend so much of my time and effort doing this, which is so rare in academia. So I want to start with the software that we make. And this is our software team. Folks in italics are alumni. Cell Profiler these days is largely maintained by Nodar Gogoberze. He also works a lot on Piximi, but development on that tool now is led by Andrea Papaleo. But Alice Lucas and Levin Moser spent a tremendous amount of time on it as well in my lab. And we had Teresa Gao and Eddie Anyongo, 2 different great MIT students from across the street over to help. We are also working on a brand new tool, which I'll show you exactly one slide about, called Bilayers, and Rajvi Shah is leading development of that tool, and she's outstanding. And those of you who are coming to I2K next month, I'll be telling you a lot more about it there. So Cell Profiler was, at least for me, my entry really into image analysis at scale. Image analysis more than just clicking through on one image at a time forever. And Ann Carpenter and Ray Jones, the winter of 2003 to 2004, put that together, and I'm incredibly grateful that they did. I joined the group about here-ish. So David Logan, Mark Bray, Alan Goodman, Claire McQuinn were all huge mentors of mine and sort of taught me a lot about not just writing code, but engineering. And I think part of the reason Cell Profiler is still used, and hopefully some of you will be coming to learn about it on Friday, is because from this very, very early inception, there has always been at least one biologist on the development team. And so it is designed with biologists in mind. And there are a lot of different things you can do in Cell Profiler, but every single one of them has help text written by someone whose original training is in biology. This is now to Cell Profiler talk, so this is the one slide I will show of the tool itself. What makes Cell Profiler magical is the pipeline panel. You can make a no-code, reusable, reproducible image analysis workflow, and you can do it in a way that then future you or your collaborators or the people who read your paper can know exactly what you did and verify it for themselves. The other magic part is, of course, that help button, which again is next to every one of the almost 1,000 settings in Cell Profiler. It's a lot. They're searchable. You don't have to memorize it. But one thing that we find ourselves coming up against more and more in Cell Profiler, and it's going to only get worse as the field pivots more and more to deep learning, is installation. Installation is not fun. It's not fun if you're an expert. It's really not fun if you don't know what you're doing and you're scared to do it in the first place. So that's why we've been really sort of trying to move a lot of stuff into containers and web tools, because then the installation happens actually by the developer, and the user doesn't have to install the software, which relieves a huge pain point. And so we just put out the preprint form. We'll probably submitting the paper next week or so for a tool that we call Piximi, whose original inception was about 8 years ago, was what if Cell Profiler were a website? Piximi.app, we're calling an images to discovery web tool. I'm not going to be able to tell you about the tech stack here, but again, come find me at the reception after. But the idea for Piximi is you can bring in your images and you can do things like find the objects in them. So here we're manually annotating objects, but if you have a pre-trained segmentation model that you like, Piximi will help you bring it in. And we're talking about deep learning-based segmentation here, which is, again, the stuff that's really sort of revolutionizing the field and working quite well. Or a classification model. So here this is in real time, learning a classifier that can tell the difference between cells with no GFP, cytoplasmic GFP, or nuclear GFP. And then go in and measure all of those different classes of objects that you've found. And you can do all this in your web browser, but without uploading your data to a central server. So we don't know about your data, we haven't seen your data, but also you got there on any device with a web browser and you never installed anything. So we're very excited about this tool and hopefully sort of expanding it and making it even more useful. And the last thing that I want to just sort of quickly show again is a tool that we started developing earlier this year that we're going to call bilayers. This is not actually a screenshot of bilayers, but this will give you sort of the idea. It's pretty easy nowadays if you're a software engineer to put the application that you care about in a software container. And what if when you did that, you could very easily then get an interface. And here in less than 45 seconds, I'm going to show you me looking for the piece of software, finding the piece of software, downloading it, and then running it and never touching the command line. And what if you could do this for any deep learning model that you could think of really easily, programmatically, without any work from the developer? So that's the goal, that's the idea. Come talk to me about it in about a month. Or come talk to me about it now, but you'll see more in a month. But certainly, again, coming from somebody whose original training's in biology, we don't just want to build tools for the sake of building tools. We want to make sure we're building the right tools, which means we need people in the lab who understand microscopy as well. And so that's the largest part of the lab by headcount. Again, here we have some alums in italics, Rebecca Senf, Callum Thomas-Koya, Mario Cruz, David Sterling, Barbara Diaz-Rohr, Nassim Jamali, Pearl Ryder, and 4 fantastic visiting students we've had over the last couple of years, Fernanda Garcia-Fasa, Melissa Gillis, JJ Zhe, and Maureen Zecchi. But among the current folks, Erin Weisbart leads our development team and sort of helps all of these people learn more about image analysis. You'll hear why I say that in just a second. And she's doing that in collaboration with the fabulous Kamal Hamid, Laideo, Paul Llanos, Esteban Miglera, Shadavisha Dasgupta, and Suganya Sivagur-Nathan, who again is here and will be doing a poster. And so we take the software, in software engineer parlance, we eat a lot of our own dog food. And we take the software that's developed 2 doors down in the software engineer room, and we use it in the image analysis room to actually solve biological problems. So these are all images from that COBA center that I mentioned that we run with Kevin, where we try to find the absolute hardest image analysis problems and solve them for people. And almost all of those names that I just said, other than the students and Erin, are members of the postdoctoral training program in bioimage analysis, which is an idea that Anne originally had and we sort of cooked up together about 5 years ago, where we take the best folks from the wet lab microscopy side and we turn them into the best computational biologists. And this program is outstanding. Those of you who are at BINA heard me talk about it last year, and we've been able to pull tremendous talent, and we've been able to pull it from everywhere. We've had an incredibly strong applicant pool. And I won't tell you much more about it because there is a paper you can go read, and because Suganya is going to be doing a poster on it. So you can hear all about this at her poster, and she will explain what it's like to be in the program better than I can. But we tried to do things like actually look at what was valuable, both to people who are in the program right now and people who had then since left, and what was helpful now in their future careers. We asked them to rank things. It turns out everybody values different things, which is good but also bad, because then we have to do everything. But what we definitely found out was that training like this, when it's delivered in the way that we do it, which is described all in the paper, can really impact the trainees and their goals and their futures. But to take things back to empathy, these are all people who are trying to do this while learning something big and scary. And so making sure there is space for being wrong and asking questions and it being okay to be wrong and not know stuff, we have found is just such an incredibly important part of doing it. And so we really try to create that atmosphere. But the side effect of hiring incredibly brilliant, incredibly kind people and then teaching them stuff is that as a side benefit, they also then teach other people the same stuff. And so the things that have come out of this program and that are countable, and there are certainly a tremendous number of things that are not, it's probably closer to 100 different collaborations that our postdocs have worked on. They've created a tremendous number of papers, and typically things like protocols and tool papers, so it explains the citations, but again, also the helpfulness. They've run a bunch of tutorials. They've even created new tutorials or created tutorial translations. Again, you can find these all on our website, and there will be a QR code at the end. They conduct office hours, which are open to the public. Anybody can come and sign up for our office hours. I hope some of you do. They make blog posts, as well as something called the Bioimaging Guide, which I'll get to in just a moment. And they've posted on the image.sc help forum, which again, I'll tell you more about in just a minute, almost 2,300 times. And so they take this knowledge and it doesn't just go to these amazing 12 people, it then goes from them to the rest of the world. And of course, we're not doing this in a vacuum. Of course, there's one of the amazing things about working in this space is how many kind, helpful people work in this space. And it turns out when you work with people who want to help others for a living, it's actually pretty nice to do that. And I think the best example of that is forum.image.sc, which is sponsored by COBA and originally started as part of COBA, but has now grown to more than 60 different open source software tools. And there are people who post on there hundreds or thousands of times a year helping other people, largely not because it's their job, but because they just want to help other people. And so this is a resource for everyone from beginners to experts that has grown far beyond what our sort of smallish team at a time can do. And another great thing you'll hear again more about tomorrow is the virtual I2K, which we've been doing with BINA and Globius, and virtual I2K would not exist without Vanessa, so thank you, Vanessa, for that. Where we open up a free Zoom room and we say, we're going to let people teach any tool they want. We're going to let people attend any tutorial they want. And last year we had 30-something tutorials and 500 plus attendees, and we're going to try to beat those numbers this year. So if you make tools, give a talk. If you don't, or you just want to learn about other tools, come listen to a talk. And so we try to identify what we can do, what our lab's special skills are in order to sort of help all of the other efforts in the community. And I just want to highlight a couple more briefly. And one of them is that there are already a lot of people working in the space. Many of the citations here are to people in this room in terms of great resources for both imaging and image analysis. So working with the BINA Image and Informatics Training Education Group, we wrote a paper about it and we collected a whole bunch of resources. I was also lucky enough to get to be on QuarUp Working Group 12 and think about how we can tell people how to document their imaging and their image analysis workflows. And again, we wrote a paper about it, and that's great. The less great part is that these become out of date extremely quickly. When you have a list of resources, the second a new one comes out, your paper is not quite as good as it was before anymore. They're also kind of a giant wall of text, you might have noticed. So I've been helping out QuarUp with turning this into the checklist into a Jupyter book, and Mike Nelson, who's here from Kevin's group, has been really important in this effort, where we can make things clickable and friendly, and you can have description and even links to how-tos, which will hopefully, and it can be updatable, so as recommendations and standards change, this website can too. And again, I mentioned the paper that we wrote with the Image Informatics and Training Education Working Group. We turned this into a website called bioimagingguide.org, which is your guide to what you don't know about imaging and image analysis, and a place where you can go learn it in a way that's non-judgmental and friendly. We can leave notes in the margins and things like that. And again, as new resources come out, we can keep it live and updated. And because this is on the web, the other great thing we can do is we can give it to everybody around the world, and we're delighted to see how many people in other places are using it. And we can translate it also to make it easier for beginners to access these resources in whatever language they're most comfortable in. This is the Spanish version, which Mariana did basically single-handedly because she's amazing. We have several other versions. I'm happy to talk more if anyone wants to make one for their favorite language. So in closing, there's still a lot of problems to solve and a lot of work to do. This is, again, from that same paper. And we spend a lot of our time thinking about image analysis and data interpretation, but often people come to us with all of the images they were ever planning to make already acquired. And that's a problem because maybe if they had acquired them differently, if they'd done some pilots and let the analysis feed back, they might have been able to learn more from their samples. And so how do we sort of promote this model in general, and how do we promote it to people who don't know we exist, is a problem that keeps me up nights. But overall, compared to even just a few years ago when I started in this space, things are so much better, and there's so much energy and so much effort, thanks to a community that is working together, and thanks we did work hard. And so with that, I just want to thank the people who paid for this, the people who do this, collaborators, mentors, friends, partners in crime. You can decide who you are on that list. And I think the only person who's current member of the lab that I didn't get a chance to shout out is Ksenia Krishina, who is our administrator, who makes sure that actually all of this stuff works and happens and is paid for. So thank you again. Again, I really can't explain how much this means to me. And I look forward to chatting more with folks at the reception. I'm really shy and I'm probably not going to introduce myself to anybody I don't already know, but I'm happy to talk to people if they come talk to me first.